your presentation. That will be helpful. Perfect. Thank you.
Are we all good? Okay. I have another thing for my LinkedIn, but you can find it. There's not that many Adrian F. Coles. So, yep, I work at Elastic, and I'm working on this something called Open Telemetry. And if you're not sure what that is, I'll give a quickie on that later. And my disclosure is I've only been working with Gen AI, generative AI, which we'll talk about half a year, which is some pros and cons to it. One of the pros is that I still remember all of the bruises. I still have many of them. And con is that you may have a question later from me that I may not have the answer to, or someone else here could answer better than me. But I have read a bunch of stuff and I have worked in it, so hopefully there's some helpfulness through this presentation. And we'll go through a few different things here, like what is this Gen AI including? Why is there a Gen there? And then how do these things connect, basically? And it seems like I need to mute myself. Okay. Online. Okay, this doesn't go into Zoom. It's the great. Okay. All right. Let's do this. Okay, so the first thing you can scan while I'm talking. AI, if you're in Kubernetes world, CNCF is sort of like the owner of Kubernetes, the foundation that it's in. And the runtime of CNCF is Kubernetes. So the technical advisory group from CNCF is where the actual AI, a lot of the spearheaded AI research is going on in the world of Kubernetes. And so that's beyond Kubernetes. It includes all the different projects that are in CNCF and beyond. So if you're curious about like where to go to, one of the places you could do is use that QR, which doesn't give me any Bitcoins, I promise. It just points you to that website, and you can follow up with later if you like. So we're going to go through basics of Gen AI. And first off, the Gen stands for generative, not general. So if you read some blogs or listen to some podcasts on AI, there's this thing called AGI, which is like the future thing where there are basically these things that can do everything you can do better than you. That's general, artificial general intelligence. And we are not there yet as an industry yet. People say maybe 5-8 years possible, but the G in AGI is general. Gen AI is generative, and it means that it's creating some new data from some data it's already seen. And in simplest terms, so I went to anybody here went to the GovTech Stack thing last month or whatever, the Stack conference? There was pretty good presentations there. And one was, I think the CTO of GovTech was saying that, if you think about the first generative AI type of thing, behaviorally would be like autocomplete. You type in some letters, it's guessing the likely next ones. Of course, it's not necessarily AI, but it's sort of the concept of generating something given something in it. Now, this is about classification of what Gen AI is. It's a causal language model, means it goes one way. So it has information, it can produce new information. It doesn't necessarily go back and to things. So it's about prediction. And also, one thing important is that, how many here have heard of the term LLM? LLM. So LLM is a large language model, and it's a type of a generative model. So when you hear Gen AI and LLM, sometimes people mix and match them because they're sort of like similar enough. And that's why you can sometimes find some confusing technical articles, which might say Gen AI, and then sometimes say LLM, and sometimes whatever. Just forgive it that. But one reason why you could say generative model is a better way to say it is Gen AI is more than just language. So people have seen these things that can create even like movie trailers now, or like read your screen and transcribe audio for you. So that's not text language models, like, so generative doesn't have to be limited to text, and that's one of the reasons why some people will also choose to say GenAI instead of LLMs. But sadly, they'll still use LLM to say something that's about audio sometimes, just whatever, just accept this. Now, if you've never used something called ChatGPT or similar before, the flow usually is, you as a user, say something to the assistant, like if you're obscure geography quiz and you're wondering, okay, what ocean has this Bouvet Island in it? And then if it has seen that information, oops, that's a bad place. If it's seen that information before, then it will be able to correctly answer that question, or it's likely to. And the reason I say that if that text was in the data it was trained in, because a general model does not need to be specifically trained for geography or specifically trained for your favorite Nasi Lemak recipe or whatever. It has the ability to create, generate some new information, response to something, even if it wasn't like specializing in that topic. So, for example, you're not going to find, like, very likely you're not going to find an LLM specializing in hawker food. It's just if it had a lot of text and information about hawker food, which it's likely to have had, then it may be able to answer some questions that you'd be surprised about. On the other hand, at the same GovTech conference, they were talking about this thing called Lion Guard. Anybody heard of Lion Guard before? So Lion Guard is a way to safely use an LLM. So like maybe you can know if something's abusive coming in or out of it because somebody's asking an abusive question or whatever. But what's a challenge here in Singapore, right? It's English. So it's trained to understand Singlish and all of the abbreviations everybody uses so that it can understand the difference between like what ABCDE might mean in a context of Singlish, which a normal LLM might not know. So sometimes they are specially trained, right? And there are use cases where there could be something like that. I hope that's interesting to you. So one of the reasons why we like LLMs is that they can know what you meant, mostly. So you can feel free to misspell things. If you try to do the same thing in a database query, good luck, because you're limited in syntax. You have to do like query or something like that. You have to at least match a substring or similar, whereas you can just completely mix up your characters. And the reason that works in an LLM is because there's a statistical significance of a misspelled word to its correct spelling word. And so they will have a higher probability of the same next information. The other thing we like about LLMs is that notice that these are in a human language. And so it's not required to be structured in like a SQL expression. So like not like select thing from thing from thing from thing, where if you put like an equals where you're not supposed to, the query will completely break. So you don't need to know any syntax per se. Now there is this thing called prompt engineering. I'm not going to go into it. If you want good information, you should know how to ask the question, but it's very forgiving. And so that's one of the reasons why people like these LLMs. And so basically, it's trained on language so it can compensate on slightly off input. How many people here know about Alibaba? Got to be someone who says, yes, do that, please. So one of the models, one of the Gen AI models, an LLM made by Alibaba, is called Qwen. And Qwen is trained, I think, currently in 32 languages, maybe even more, I forget. I don't remember if they're even counting English and Chinese. So I think it's English and Chinese plus 30 more, including Malay. And I was listening in Malaysia before I moved to Singapore. So like it's pretty cool. So there's a lot of opportunities you can have when you have something that can understand many different languages. Bada bing. So if you did know Malay, then you would be able to understand what this question is, which is the same question. The other thing was, what ocean contains Bouvet Island? And it could answer back, even though the information in geography could have actually been in English. So when it was going through its training data set, it doesn't mean that this was from wikipedia.my. It's not important because the language aspect is different than the source data. So that's pretty cool. And then the thing that LLMs have, which is a con, is this thing called hallucination, which also happens in humans. I mean, how many times have you misremembered something? That happens for me all the time. How many times have you had someone tell you something assuredly, which is totally false? That is also happening with humans. So we can forgive it a little bit, but it is a problem in working with GenAI because, for example, we can come up with an assured answer that's completely wrong. So there is no capital of Bouvet Island. It's actually just penguins there. So they don't have a capital. They have like a settlement for some researchers, but it's not really like a thing. And so this is a problem with LLMs where they don't really know the difference between right and wrong. They just have statistical correlations and they're trying to complete that text. And so you'll find some other techniques to work around that, which we don't have time to cover because I have 30 minutes. Then the other challenge is that you'll hear something like, if you follow AI news, it'll be like, oh, OpenAI has this new thing out, or Meta from Facebook has this new thing out. And new does not mean it has new information. It just means it's like a better performing model, or maybe it does something else. Sometimes their training data is still like a couple of years old. So that training date is documented in some cases, but it's not always documented. Like when was this training cutoff? And then so they may be trained differently, and they may just have no information about specific topics. So in the case of Lion Guard, right, they may not have a lot of context about the abbreviation of the week here. Because of that hallucination thing, you get to double down on the problem. So say you ask it, when is your training cutoff? It may lie to you and say, oh, it was yesterday. But anyway, these are just some constraints to know that the information it hits a ceiling. And of course, they're usually trained on public information if they're published LLM. So they're not going to know about your company's internals. So I made this one at a Go presentation sometime and asked, and then in this case, it was able to say that its training date was blah, 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 but I think it's actually not quite correct, that answer. But at any rate, if you want to have recent information, there are ways to pass information in the context of when you're making a question. Like say, I'm going to make a question like this. Please see this information. It could be text, or some tools will allow you to just like drop a PDF or whatever into it. And so you can add information. And then there's sort of like a database technique with vector databases, like Elastic is, that it's called RAG, which for people from India, they love that one, right? Because there's so many people named RAG. But RAG in this case stands for Retrieval Augmented Generation, which is super fancy for just get it from the database. Okay. And so basically there are ways to optimize this question answer. And what happens in RAG, in brief, is that you actually change the question itself to a numerical format. And then you run like a similarity search against text that you've already loaded into this vector database. And then it will come back with like basically chunks of text which are relevant to that question because it's knowledge of words here. And then it would just paste those behind the actual question someone made to true it up. And if you want more like concrete examples of that, just ask me later. So anyway, the first thing we always see these AI things for are like chatbots. things like AI assistants because they leverage the strengths. You don't often need perfect support. I mean, anyone here has ever gotten consistently perfect support from like a support chat, even human? Maybe, actually, I was thinking about, maybe one day you're gonna have the hit O for operator and then the like 2 for the AI. And maybe sometimes people will say, actually, the operator is really difficult. I'm gonna use AI instead. Like, then we may get to that point where people just prefer the computer. We're probably not there yet. But the assistants are leveraging the strength of the LLM. Obviously, if you're like AirAsia or something, there's going to be some booking information it's not going to have access to. So there would be some using of RAG or some other technique to add that data. Or if you're dealing with like, like I said, with data that you might feel people are asking like abusive questions, we use guardrails technology to do that, to restrict the information coming in and out, and line guard is an example of that. And the reason why this can be used for assistance is because humans can accept latency if they're getting a lot of value out of whatever they're doing. And if you're typing in a chat and something takes a while to respond, well, so would a human. So if you're chatting with a human, they're going to take a while to respond. So that's one of the reasons why chat is pretty good app choice. Okay, so that was the overview. I did that because I didn't detect like everybody like already being like super expert at this. Helpful? Helpful, okay. I almost got a hand raised. But I got the nods. I'm still getting used to the differences here. So open telemetry. So people here have seen open telemetry before, at least the logo. Metrics, monitoring, stuff like that. Latency, how fast your website goes or doesn't go, errors. So the reason I'm covering this is because my presentation it's called What's Next for Observability. So I need to talk about observability. And so in this case, we have like 3 different things that are usually talked about. We've got logging. Everybody knows how to log, because if you've done your first computer program, you say print hello world. And so like console is basically like a log. So that's your first log statement, right? So good enough. But logs are where all your errors go. They're discrete events. They're indexed by time, usually, well, always, basically. The tracing. Anybody here use tracing, where you can see like this HTTP request called this database and then does things like that? Some people have. I'll show a diagram what that looks like. But it's mainly helpful for you to like pinpoint, roughly speaking, why is this slow, right? And then metrics are different because these are aggregation. It means that like, not like why was this specific request so slow, but why is everything so slow? Or why is everything coming from wherever so slow? Or everything into this pod is so slow? So it's an aggregation, you're taking like some sort of population, and then you're getting like 99% are doing well, but that 1% aren't so good. Stuff like that. So we can convert these things one to the other. So like if anyone are using like this thing called logstash, then you can take a log and then you can try to like extract fields from it. Maybe one's called duration, and then you can like roll that up together, and then you can get metrics out of that that you can use in your alerts or whatever. So there are ways to convert some of these to each other. And it's kind of cool when you can stitch things together, because then you can have a discussion with whether it's you with your admin cap on or whatever. Oftentimes if we're microservices, the microservices are named. And so that name or label that you put on things is helpful. App label or the pod. If you think that there's a troublesome pod, like being able to like search everything together. And then of course, the things that are rolled up, like metrics, you can't unroll them. So it cannot go into a single request ever again. But you can still connect the things that are, if they have like the same field in the log as a trace. So that's sort of like the gist of it. And so just like everything in technology, there's strengths and weaknesses. Logs are great if you have a monolith. Everything's there anyway, so just look at the logs. Black boxes, like a cloud service you can't affect, or some vendor software that you can't change. And of course, anything exception like errors, they always end up in logs, right? Metrics or for patterns, that's how we do alerting, that's how we get woken up. That's how we do our SLOs. And then traces are for the why it's not slow. And traditionally speaking, we're focusing on like how to collect this data. And we try to make sure that we prioritize the things that are important. So like, I don't care if my favicon.ico on my website is like performing slow, unless it actually affects my webpage. So like we have, as systems people, we're gonna end up trying to like prioritize things and get good use out of our logs. So now finally through this intro stuff, I hope it's helpful. Where do these things connect? So basically it can go both ways. If you have AI, because AI can be very expensive to run, you probably want to know how it's running, like how much tokens and things like this, that this is accumulating because there's the things that you build on. On the other hand, AI can even help you with your whole monitoring setup with your observability stuff. And that's what I'm going to talk about next. So this is what a normal trace diagram looks like. And if you had like a normal web interface for a chatbot, and then it's trying to pull information about a client because that's not in the LLM because it's private information. So it's probably going to do something like this. Check the index exists, try to search through that index to find information that's going to be helpful for this question. And then go and actually execute it against whatever that large language model is. And then you would be able to see that the actual large language model is usually going to be most of the time as a long time. But so this one is like 11 seconds. But like, these LLMs can take a long time. They can take shorter ones, but they're pretty long. So basically now the database people are like, ooh, something slower than us. So open telemetry has a special interest group stake on this topic. So at the very first slide, I said like, okay, you've got Kubernetes land itself, CNCF, runtime, has AI research. So the monitoring group called OpenTelemetry, which is like a buddy for Kubernetes, the second largest project in CNCF, Kubernetes being the first, is this one. But they have a specialized area for GenAI. You can, if I get out of the way, you can see that maybe. But what it does is it basically makes a schema for the data that the LLMs produce and that you can monitor. And then also some stuff for your Python or JavaScript apps that might be interacting with LLMs. Python first, because basically everything data science is Python. And so in the case of this, like traces, you could say like what system it's called, if it's OpenAI, if it's Cohere, if it's Amazon Bedrock or Google Gemini or XAI, Grok, whatever. And then how much token? Token is basically similar to how many words are sent in and out, because that's what everything is built based on, is this idea of token. They don't use word because what in Chinese, right? It's like how many letters? It's not in letters. So they have a way to translate into a billable unit that can be used regardless of whether it's text or other things. And then metrics, of course, latency and things. And the logs are very important in the case of GenAI because that's actually the request response. Like what question was actually asked and what did it return? Because there's some nuance to that. So the reason there's nuance is that GenAI is basically coming out of like data science and ML and deep learning and all these other spaces that more than like web server land. So there's a lot of overlap in ML ops than there would be with traditional systems engineering. And so, yes, you have things that you could become familiar with, but of course, calls is added into the trace if certain providers can look up that information. But evaluations is very important. And I say Langtrace defines these pillars because there's a contributor to OpenTelemetry. They have an open source thing called Langtrace. And they have some pretty interesting stuff. But basically, when these questions come in and out, there's this concept of, like I said before, is a hallucination, is it even getting a correct answer? So evaluating this request response is important. Because it's not facts, really. So things are more subjective in this case, so you need to evaluate, or someone's gonna be evaluate, is it actually thumbs up or thumbs down? You've got a good answer, bad answer. And so there's manual and automated ways to do that. And there's also these data sets that are used. So for example, you might want to hint something into the good direction by saying this is a good example of a positive answer to a similar question to keep it on track. So because people, when they get into the quality, like test QA world, they may actually have a different opinion of what observability should be doing because of this anchoring to ML. And this is a wall of text, sorry about that. But I'll just pick one or two here. So I already said accuracy is subjective. This is not factual, truly system. It's not like I made the request to the database returned the rows or did not return the rows. This is like, did I ask it about an island and it answered me about ice cream? Like the accuracy. And of course, the main thing here is that like, if anyone knows when like cloud first came out, some people won't be that old, but like that Amazon was basically the only one. And so people thought like cloud is Amazon or cloud is Salesforce or something like that, when there were just so few things going on. So one thing that's very interesting about Gen AI is that OpenAI is a very dominant force in the whole consumer even world. However, it's a very diverse ecosystem. There's many, many different things. And so that actually has a lot of impact on how technical stuff plays out. So with the last part here, go about observability using GenAI, which I think is kind of interesting. And when you're doing observability or monitoring, if you don't like that name, first off, you can think of it as like, there's a few things it can do pretty well. It can assist analysis of things that you already have, like dashboards. It can help you extract patterns so you don't have to like memorize them and then figure out how to do the config file. It can configure your data sources for you because it can understand patterns and things. And also interesting things because it can understand language. You could connect human language type of stuff like help desk tickets with your system information without the manual labor that's usually required to do things like that, or even source code to applications. So yeah, so for example, if you have logs, one of the things in Kubernetes world is we know that like Kubernetes has a lot of releases. They include new functionalities from like 1,000 different people. What do they do? Oftentimes they change their log formats. Maybe there's this thing is not even there anymore, or this new thing is there. And if you're doing your upgrades and you have your stuff set up, well, wouldn't it be nice if something could just like, go reconfigure everything for you so that whenever like 1.44 is out, it's less work for you. Also, like we did these things like stack traces in our code because something blew up. Wouldn't it be nice for somebody to figure out that, oh, that stack trace was related to this change for you. So you don't have to like find somebody smart enough to do that. And so some real world examples is K8SUG. So K8SUG is kind of a play on ChatGPT, but basically it's an open source tool that exists now. And what it tries to do, sorry about the reading might not be so easy, but it tries to take a fairly cryptic log, because I know I actually talked to some people who are just like starting with Kubernetes, right? They may get some like weird esoteric thing like error, back off pooling image nginx : 1234. Now people who have worked in Kubernetes a long time, they're gonna know what that means. But what does that mean? So what this would do is it'll translate the cryptic thing to like, that means the Kubernetes pod is having trouble pulling a specific image. Verify that this exists and try to make sure that you can connect to Docker Hub. And then it can like kind of like start unpacking the error for you. So that's like one of the things it does. And if you're interested in more, just click in there. At the actual project. Kibana is a part of Elasticstack, and we have this thing called Observability AI Assistant. And so that means that when you're like searching your dashboard or your Logs Explorer screen or whatever, it already knows what's on your screen. So then you can start asking questions about it and it will know that context for you. And then there's this thing called knowledge. There you can connect things like help desk tickets and stuff like that to it. So you could actually have it help you get to things, or even like execute a runbook for you, or suggest what your SLO should be. So this type of features are things that you'd expect like observability assistants to do, because those are type of tasks that like systems managers need to do. And then one thing, this sort of I think this is the last example. Importing, if anyone has data feeds that they're working with, you're taking information from somebody, and there's some certain important fields in that data. Like somebody give you a CSV file, right? This could actually, you put data into a S3 bucket, and it can actually figure out what the fields are for you, based on its own internal QA process. And so you could actually, it's a self-training thing. So it's helping with the integration glue. I'm gonna just skip through because I think we don't have any time. So anyway, we're in Singapore. What to do next? Here's some things you can click if you like. First of all, Elastic, my company has this thing called Elastic On, which is happening in a few months at Sans Expo. I'll be there just like helping with the community. It's not all about AI, but there's definitely AI there. If you're a coder, you can join me at GopherCon Singapore. I'm going to be going to that. I'm talking there about like how to do GenAI programming. And if you like this blog stuff, like you want to look at, I work there, so I'm biased, but actually there's a lot of cool stuff. Make your own decision. If you like system side of this whole GenAI space, it's not all GenAI, but there's a lot of stuff there. And so let's close it up. And I think I'm out of time, but if you want to get me later, just leave me a hoot. So thanks for your time.
Thank you so much, Adrian.
Yeah, let me check. Okay, let's start, guys. Siva in front of you. Still connected. There's a display connection. What happened? Is it laptop? Catching here? There is a this side is. This side is. Wait. Technicians are here.
Done, almost done. Yeah. Is it connected?
Does he, do you have HDMI?
Oh, yes, I have.
Why don't you just direct HDMI this?
Okay.
Don't drop.
Yeah.
Here. I think it's here, bro. This is HDMI. Here. Yeah, we just direct HDMI. Yes.
Yes, yes.
There. It's gonna work now. Okay. So after him, we will run. No.
Oh, yeah.
Good to go. Start.
Okay, thank you. Yeah, hi everyone. Am I audible? Okay. No problem.
Just be quick.
Okay. Yeah, hi everyone. Am I audible? Okay, good evening, everyone. I will not take much time. It's like very quick since we have a very good hands-on lab session. So I just wanted to go through quickly. Okay, so this is all about deploying a cluster, and mainly to customize some of the parameters, systemctl, I can say maybe node OS specific configuration to automate to customize the configuration changes when you have nodes are scaling, while workloads are, I can say, increasing. I can say when there is an application demand, and to scale multiple nodes or number of nodes in the node pool to customize the configuration changes while it is scaled. So normally, maybe yeah, when you have an application requirement, I come across most of the admins what they are doing manually when there is a node add-in, log into the node, each individual node, and then applying the configuration changes. So which I feel more manual workaround, and then again time consumption. So again, when there is nodes are scaling, it may be a difficulty to track what are the nodes are scale in, scale out. Yeah, when it is a scale out, shouldn't be any problem when there is an scaling. And then if an application required a custom configuration to be applied on the specific node to meet the application requirements, then configuring these changes manually bit troublesome. So that's where there are options. It is not something I invented. So there are options within Microsoft Azure portal itself, and we can apply some of the configuration, how to apply the configuration, and then enable on the node level without logging into the manually. So I'll okay. By the way, I am Shiva. I am one of the organizer as well with the K8SUG. Thank you all for coming and joining the session. Okay, so here is the one. I'll just go through overview of AKS, and then overview of auto scaling, overview of node customization, and then deploying, or maybe I can say a demonstrate, and then how this configuration to be applied in all the nodes. Hope it will works. Okay, so yeah, so overview of AKS. AKS is a managed Kubernetes services that you can use to deploy and manage containerized applications. So the mainly why we are talking about AKS, it is one of the cloud, I can say Azure, Microsoft Azure cloud, where by choosing AKS, maybe there are even it comes from AWS or GCP or Oracle cloud, where every cloud vendor provides containerized application hosting clusters. And when it comes to the AKS, yeah, the master plane, I can say control node, and then specific configuration, it takes care by the cloud provider, so that as we admin, maybe nowadays we don't need an admin as well. Application teams itself, they are deploying a cluster and then managing on their own. So the application or engineering teams, they can manage, they can focus more on their development workloads rather than maintaining the underlying cluster resources. So that is where the cloud comes into picture, where it I can say scale in, scale out easily, and effectively utilize the compute resources, and then high availability. So that there are various use cases to choose a cloud and then host a cluster. And it reduces, yeah, it is all about reduce complexity and operational overhead. And then it can be the cluster can be run in on-premises as well using the HPC stack, I can say Azure stack. Maybe if it is not AKS, you can still deploy a cluster with maybe Rancher or whatever tool available. There are various tools available. One of these is Rancher. So yeah, so mainly we choose because of the scalability, auto scale, nodes and pods when there is a demand, and high availability when you choose AKS. If you are deploying a cluster in a specific region, every region comes with more than one availability zone. So when you choose a zone more than when we choose creating a cluster, there are options to choose availability zones, a zone 1, zone 2, zone 3. So each zone at least more than one availability zone. So if you don't choose availability zone set to none, then comes with a no redundancy. So ensure if it is a production tier 1 applications, ensure you choose zone 1, zone 2, if in case you want zone 3 as well, so that for instance, when there is an issue with the one of the availability zone, for instance, maybe power down or a storage issue, so some other whatever, maybe network issues. Recently, we come across some of the issues like DC power down. So the stack itself went down. So whatever hosted applications, they are not accessible. So choose availability zone more than one. So that, and again, when you are deploying a cluster with ensure don't deploy any applications on the master node, because that is managed by vendor, and create a dedicated node pool in the cluster for your applications to deploy. And while deploying a node pool, choose zone 1 and zone 2 if it is tier 1 application and wants to have a high availability. Okay, so choose zone 1 and then zone 2 and create two node pools, one in zone 1 and another one in zone 2, so that you will have a high availability on the availability zone level as well. Okay, so that it will be up and running at any point of time. And then, yeah, load balancing, resource isolation. Resource isolation is all about when you have a cluster sharing between multiple teams, then you can create as many namespaces as you want. It's kind of resource isolation, isolating namespace workloads between one team to another team, and then enable role-based access policies and provide access to the particular team, so that and also set a quotas. If in case a shared cluster, you can set a resource quota and ensure maybe a project A can within the limit. I can say they should not over utilize the compute resources, so that the project B may have come across the I can say resource constraints. So yeah, there are various various ways to deploy a cluster and then enable access and then do all these customizations. So in that, again, a load balancing, when there is a huge in traffic, it evenly distribute the traffic among the nodes, across the nodes. Yeah, management layer. Yeah, when it comes to the cluster management, most of the time, yeah, control plane is managed by vendor, so that you don't need to maintain the underlying Kubernetes. Yeah, when it comes to the version upgrade, those are all, yeah, definitely we need to do, but you can still set scheduling as well to automatically upgrade version when and then there is a version released. There are options to set N-1 or N-2 or preview version, whatever preferred or required based on your organizations, or I can say policies. So here is the control plane. I will not go through each individual component. Maybe a control plane, which is called a master node. It comes with the API server, scheduler, etc. Database, and controller manager. And when it comes to the customer managed, what we are referring to the node pools. So when you want to deploy applications, you better go with the user node pools or application node pools. And each node comes with these are the components, I can say Kubernetes, container runtime, and proxy and container. These are the components comes with each individual node. So these are the main components to interact with the control plane when it comes to the scheduling and interact with the APIs, and then ensure that it ensure the key value data. It's one of the I can say important database to hold all the cluster state. So these are the some of the components comes with the master node and then cluster user node pools. Auto scaling. So yeah, auto scaling. There are various approaches. Auto scaling is all about when there is a demand, and when you initially we may not have. I can say based on the application demand, you may configure a node pool with the minimum one node or maximum. You can set as many as you want, right? It again as many as you want, in the sense there should be a quota available within the subscription as well. Okay, based on your available quota, you can set maximum. And when there is a workload demand grow, then there are options to scale the cluster, like One is manual scaling. So manual scaling is all about getting into the cluster or getting into the portal. And there is options to scale node pool. You can maximize the number of nodes as you want. Or there is Azure CLI command line as well to manually scale number of nodes in the node pool. And then using horizontal pod autoscaler. So when you deploy a HPA and HPA is all about to apply an application or deploy an application and on each individual available nodes across the nodes within the node pools, I can say. So again, when you are using HPA, when there is an application deployed with the number of replica sets, if the application has maybe a few, maybe 2 or 3 or 5, when the replica count is increasing, then the same number of nodes will be increased within the node pool. So that is one of the option to scale nodes. And then cluster autoscaler. It's all about based on the resource requests and then pods. So it will automatically scale. And then again, when there is a resource utilization to effectively manage the resources, based on that you can set the cluster configuration. If the compute resources are underutilized, then you can set the percentage. Based on the percentage ideal resources, then the auto scale will takes care as well. You can set both minimum and maximum. Based on that, the cluster auto scale will take care. And then event driven auto scaling as well. There are applications like a KDA or Carpenter. There are applications. So using these tools, you can auto scale. I can say when there is a more traffic or more pods to be deployed, then the node will automatically increase based on the resource requirement. And then burst to Azure container instances. So there are options. If maybe for a use case like if you have a web application to be up and running for a while, if it is not a prod, maybe for test use case you want to deploy a cluster and make use of spot instances. Spot instances comes with very less I can say pay compared to the normal standard SKUs. So make use of spot instances, and then so that's how it will take care of automatically scale out. There is an option to, there is a parameter to set priority hyphen priority spot. So this will make use of spot instances within the nodes. Making I can say when you have a cost limitations, then make use of spot instances when deploying a node pools. Custom node pools. Custom node pools, different sizes. So for instance, you have an application, web application to deploy, to host in a cluster. So create a node pool with the required size. When there is a database to be hosted, database means it may require higher memory and higher CPU. So create another node pool with the appropriate node SKU size. For instance, there are standard SKU sizes like E30, maybe it comes with the 32 GB CPU or 32 GB memory or 8 CPU or 8 CPU. So based on the requirement, you can choose the SKU size and then create a dedicated node pool. So and then it depends. Again, the scaling options is all about either manual or auto scale. Based on the configuration settings, it takes care. Okay, so those are all about scaling, auto scaling methods and various available options to scale out. And comes to the customization scenario. So when your application, yeah, as I mentioned, if it is a database to host, it may require more CPU and memory, right? So based on the if it is a CPU intensive or memory intensive, based on that you can configure the node pool. I can say using the SKUs, right side of SKUs, and then GPU requirements. So nowadays all about AI, right, or LLM, whatever applications. If you want to host, it required a specific SKU size as well. We have at this point of time, I think, yeah, we have NVIDIA and even AMD node pools are available. I can say SKUs are available in across all the cloud vendors, I can say. So they're there, but it comes with use cost. So you need to effectively utilize the resources to minimize the operation, I can say, Azure spend or bill, I can say. So choose the required instance size and then apply maybe a labels, so that use the labels, so that if in case GPU specific applications to deploy or provision in the cluster based on the label or maybe node selectors or affinity rules. So based on these all parameters, you can deploy our application on the right nodes, right? You have a GPU node pool deployed with the GPU nodes, and but you are provisioning a simple web application and consuming the resources doesn't make sense, right? So using these are all options like node selector or affinity rules or labels. By leveraging all these parameters, you can use the you can deploy the application in the right node pool. And then, yeah, burst workloads. This is all about, yeah, as I mentioned, by using the spot instances. When you are deploying, if it is a less critical application, maybe you can have a separate node pool and then use the spot instances. Yeah, cost optimization. Yeah, as I mentioned, based on the based on the workloads or based on your available budget, you can choose the right SKUs to minimize. If you don't want to spend much, go with the spot instances and minimize the bill. And there are, if in case you need a huge demand, you can consult with Microsoft. They will give huge discounts as well when there is a specific node required. And reserved for couple of years, I can say. Maybe they comes with a number of years plan. Based on that, they will provide huge discounts as well. Availability zone. So as I mentioned, if a production critical workload to deploy, ensure you deploy a node more than one availability zone, and then use the affinity rules, node affinity rules, and when you are deploying an application, ensure one replica is deploying in zone 1, the node pool in zone 1 or zone A, and another replica is deploying in zone B, so that if anytime one zone or one availability zone goes down, the next available zone will takes care of the application availability. Okay, yeah, compliance and security. Yeah, it is all about policies. Maybe comes with the auditing purpose as well. There is an application required with X number of CPU and memory. So based on that, based on the requirement, you can choose the right SKUs as well. And scale to zero. So when there is a ideal resources, when there is no workload or when there is no traffic, and if the node pool is created with X number of nodes, then when there are no workloads are running, then there is no make sense running on multiple nodes in the node pool without having any workloads. So scale to zero. Yeah, so that is all about available options, and then some of the examples of how we use this customization. So when it comes to maybe CPU or memory intensive applications, there are options to apply system CTL configurations, like for memory intensive applications. And then yeah, there is an options, some of the system CTL parameters to apply to configure these for all the nodes when they scale within the node pools. And then maybe a scratch file size. These are all about the based on the your application needs. Okay, it is not unique for all the use cases. And then CPU configuration, and then CFS quota, and then IO configurations. So some of the various there are various options available. And again, based on the need, you can configure these. You can customize the configuration on the specific nodes. Again, sometime like we talk about based on the application, you can create a node pool, and then these configuration can be applied based on the node pool. It cannot be same configuration for all the available node pools. Okay, and yeah, and yeah, these are the custom options. And let me share how these can be applied as well. So we have next session. Let me quickly share how this can be done as well. Okay, so if you look at here, so this can be done two ways. Maybe let me show you how this can be. Yeah, so these are all the if you look at here, the customized node configuration for node pools, right? So if you look at here, there are options. The customization can be done on the Linux node pools and then on the Windows node pools. So some of the parameters, if you look at here, a CPU manager policy, CPU CFS quota. So some of these. So there are values, what is the default and what is the min and maximum as well. So based on these options, you can create a JSON file with all the set of parameters, and then use this custom JSON file while creating a node pool. For instance, if you look at here, yeah, for instance, if you prepare a Linux kubelet config file with all these parameters, and while creating a node pool, there is an option. Yeah, if you look at here, and even while creating a cluster, there is an option --kube config followed by the file. So all this, whatever parameters defined in the config file, it will apply to all the node pools. And if you want to apply a specific node pool, then again, while creating a node pool, there is an option to apply for a specific node pool as well. And yeah, so these are the changes will again apply on all the nodes when and then there is a new node is created. And when you see these are some of the parameters, there are default values, and then there are min and max values. So maybe yeah, go through this tweak which is available with what are all the configuration changes which you can go through min and max, and then apply. Okay, so and yeah, some of these mainly file handler limits, and then network components, and some of the CPU and memory. So these are all we cannot go beyond. So it can be between min and maximum values. Okay, and then yeah, virtual memory. So these are all the components. So if you want, yeah, these are the one way while creating the cluster. For instance, you have created a cluster, and you want to apply the custom configuration, and again the custom configuration to be applied while the scaling. So for that, what we can do, if you look at here, create a daemon set, and then do you see here? Some of the parameters. Whatever parameter you want to apply within the systemctl configuration, configure such a way that whatever required parameters within this command section, and then systemctl set it should be apply when there is a new node pool is coming in, and then apply the daemon set, then it will take care of the system configuration changes when there is a node pool. So the daemon set is all about when there is a new node coming up within the node pool, the application or configuration changes apply in the new node. So this is how you can automate customization while the node pools are scaling. Okay, so since we have a next session, I don't want to take much time. So this is available. I will share these all the components, maybe these commands. Maybe you can give a try. Okay, so I think that's all about what I have planned, and maybe yeah, I can say let us connect on LinkedIn as well. Okay, so thank you all for joining, and have a good evening.
Thank you.
Huh? We are done, right? We need to move to the other one.
Yeah. Okay, thank you so much, guys. So for our next event, before we move to the other event, here's Paul. Paul will bring a quick quiz. Okay, so yeah.
Thank you, guys.